Okay, welcome back to another Nico seminar series talk. We're on the second half of the fall lineup, and today we're super lucky to have Max Kreminski join us from San Francisco. He's a research scientist at Midjourney, where he leads the storytelling lab. And he's actually, recent news is he's soon to join Cornell Tech in New York City. So he's going to go back to academia and be a professor there, starting in the fall. Is that right? And so his research, he's really a pioneer at the intersection of creativity, computation, and storytelling, where his work often touches on how AI can support human imagination. And he's published in a bunch of different places. HCI venues, creativity journals, and his work's been featured in a number of places. The New Yorker is one of them. And why don't we give him a warm welcome?
Awesome, thank you. Can everyone hear me? Microphone working? Cool, okay. So yeah, I'm gonna be talking about tracing and shaping paths in design space, which is kind of the broad direction that I've been going with my work recently and that I'm kind of hoping to sort of continue on in the academic context. But before I get into what exactly that means, I'll do a little bit of intro for myself. Let's make sure the slides go forward. Okay, cool, yeah. So yeah, right now I'm directing the storytelling lab at Midjourney. That's about 6 full-time researchers and a handful of visitors at any given time. We're kind of like a weird hybrid research/product group. And we kind of do things that are both on the academic side, like publishing papers, giving talks, et cetera, but also a few things that are deployed in the world as products you can use. The biggest one is patchwork, which I'll talk a little bit about in the slides sort of further down. Before that, I was an assistant professor of computer science at Santa Clara University. I was kind of joint between there and Midjourney in like the 2024-ish range until I sort of moved fully over to industry for a while. And my research is broadly on this idea of AI-based creativity support tools, or CSTs. The idea here is that we're kind of building systems that use some artificial intelligence and some human user interface stuff to enable people to do creative work or to do creative play, and in various ways kind of enable or expand the space of things people can do creatively in some particular creative field. In practice, what this means is that I have to do a lot on both the artificial intelligence and the HCI, or human-computer interaction, sides of CST's research. So I do both the design and development of these user interfaces that kind of sit on top of an AI model, but also sometimes do fine-tuning or training of the AI models themselves, and try to kind of build like novel compositions of these like socio-technical dimensions of a creative situation. My PhD was actually in computational media, which was kind of a weird department at UC Santa Cruz. What I did there was originally technical games research. So I kind of came in with a game design undergrad, started pivoting more and more towards building these AI-based tools for game developers, AI systems that kind of sit in interactive narratives or interactive stories and kind of respond dynamically on the fly to like what players are doing. And in general, sort of trying to enable these playful forms of creativity. And this started out positioned as like sort of games-focused stuff where we're trying to build new kinds of game design, and gradually kind of pivoted more and more towards these like serious contexts that we think of in these creativity tool sort of development contexts. In the past, I've worked a lot on several specific creative domains, especially storytelling and game design and poetry. In the storytelling side of things, I've done a lot of work on trying to make it so that the kinds of storytelling that you do in games like Dwarf Fortress and The Sims, where players kind of sit down and play around with these little characters, and then sort of write stories about their experiences in these games, can be sort of used as a model for getting people involved in storytelling who wouldn't otherwise be inclined to sort of like do this long form writing, or have like sort of creative writing practices outside of this game design context. On the game design side, I've done a lot to sort of generate different aspects of games. This is actually a screenshot from a project that we did in 2021 where we generated complete Game Boy ROMs by targeting this GB Studio tool, which is kind of a visual sort of like game-making interface, as the target for an AI that generates the way that these sort of like little levels and rooms can fit together. So this is like a completely playable sort of Game Boy ROM where you can like sit down and like load it on an actual physical Game Boy and play through a game that was generated by a computer. It's kind of a strange experience. And then, of course, poetry. I personally have sort of like a computational poetry practice where I make weird systems that are using some kind of natural language algorithms or something like that to enable you to do erasure poetry, where you kind of like redact a lot of words and like sort of the poem is whatever's left over, or like find new ways to express ideas or sort of invent new nonsense and those kinds of things. So in these domains, I've sort of like focused my work in the past. I'm interested in other creative domains broadly as well, but these are the ones that I've sort of worked in the most. And this talk in particular is going to be focused on both my very recent and near-term future work on understanding how people move through design spaces. The notion here is that you have in creative domains a broad space of artifacts that could exist, either poems or games or levels or whatever. And people who are working with a creativity support tool kind of navigate or move through that space in a way that can be treated as a trajectory or a path. So you kind of look at like the first poem someone makes, the second poem they make, the third poem they make, and so on, and look relationally at how those things sort of like fit together and what directions semantically they seem to be moving in as they sort of iteratively continue designing in this particular creative space. I have these two big questions that are kind of motivating a lot of my work in this direction right now. Number one is, can we develop both empirical, scalable, and non-reductionist approaches to evaluating computer-supported creative processes? This task of evaluating CSTs, of like knowing what is a good creativity tool, yeah.
To interrupt you so early, but since you were introducing yourself and kind of your interests and backgrounds, I thought about something that would guide me through what you are going to say and trying to achieve. Mm-hmm. So you talk about interactions with machines for enhancing creativity. Mm-hmm. Now, we know evolutionarily and historically that interactions within individuals in large groups tend to develop intelligence. So social birds are much smarter than others, and kind of almost all social animals are smarter. And also, we also know about the concept of critical mass and the idea that there are these centers where people interact, where kind of more ideas emerge. And so there is a question in here, and I'm getting to it right now, which is, are you thinking that interactions with AI are meant to replace interactions with other humans? Is your thought that interactions with AI are going to be more productive than interactions with humans? So what is the kind of, this is the reason why I'm doing this?
Yeah, so broadly at that framing level, I'm not super interested in either replacing humans in the creative process or in making people more productive in a straightforward sense. I'm more interested in coming up with novel socio-technical instantiations of like humans plus machines plus other humans all working together to do kinds of creativity or to make creative work that would be hard to accomplish with just the human sitting there in isolation or just the human sitting there with a traditional computational tool. So much more about instantiating almost like novel arrangements of different species, you could think of it as, to get new sort of like forms of creative work out. Cool. Yeah, so first question, can we develop these empirical, scalable, and non-reductionist approaches to evaluating creativity tools? So it's obviously been a hard problem in the literature for a long time to know like whether creativity or a creative process is good or valuable in some sense. And so knowing whether a tool is making a positive or a negative intervention is therefore also like one of the canonical problems of CST's research. So can we sort of like look at the trajectories or traces of people's actions with these tools to figure out both at scale, but without reducing creativity to like a number of like, this is like 1 creative or 5 creative or whatever. Figure out like the way that the tool is shaping people's behavior and sort of influencing them to create certain kinds of things or maybe sort of like helping versus like not helping in various ways. Question number 2 is, can we then use these methods of analyzing these traces to build computational systems that are able to usefully and proactively intervene in the human creative process? Proactively is kind of the interesting thing here, I think. We can obviously build systems that are capable of suggesting things to people and like introducing a new idea from the machine into the creative process. But often these are experienced, I think, as disruptions or as things that are kind of getting in the way of the human's creative flow. And so the question here becomes one of, when do you intervene? How do you intervene? Is there a way to sort of intelligently look at the interaction up into a certain point, the way that a human improviser might look at another human's actions, and figure out like when's a good time to say something and what kind of thing they should say? So basically, can you sort of use these methods of assessing the creative process to then build systems that are capable of intelligently looking at a particular creative interaction as it unfolds and figure out what to do at certain moments to sort of like drive it in certain directions? And jumping right into this, I think the first question is, how do we characterize the trajectories of these co-creative interactions at scale? Yes?
Just triggered something in my mind, so I'm trying to follow what you're saying. Are you saying that the bot should tell people what to think or how to think?
I don't think either necessarily. I think what we're interested in doing right now is characterizing what kinds of interventions produce what kinds of creative behaviors. so that we can then start to develop a better value judgment around that. But right now, we don't even know like what happens when you make a certain kind of intervention in a creative process. And so this is very much like that first stage of characterization work, trying to figure out what even happens when I make a suggestion at a certain time or when it has that certain content related to what else has been said before.
Okay, thank you.
Cool. Okay, so how do we characterize these trajectories? This is kind of the big question and the one that's been driving a lot of my work recently. Just again, to sort of like give a bit more context on what kinds of tools we're looking at here. Broadly, I work on mixed initiative creative interfaces. These are systems where there's both a human and an AI that are both somehow intervening in or updating a creative situation or producing artifacts, which are these individual sort of like pieces of creative work, which might consist of images, might consist of game designs, might consist of lots of other things. And the idea here is that because there's a generative model under the hood, which might be learned from training data in the case of neural network-driven creativity, or might be defined by rules in the case of more traditional symbolic AI approaches or expert systems, this underlying generative model can be operated in an unguided or an autonomous mode, where it sort of generates artifacts on its own, and then sort of proposes them or suggests them to the user. However, there's also an interface on top where you can sort of manually steer or control what the generative model is doing, or sort of filter the space of things that it could make to a narrower subset of that overall space. In the traditional sort of symbolic sense, I've worked on things like Germinate on the left-hand side here, which is kind of a constraint-based interface for rhetorical game design. The idea here is that on the left-hand side, you kind of specify a bunch of things that might be in your game, such as like you might have a game that's about your friends and your depression and your confidence levels and those kinds of things. So you specify those as entities and resources that can change over the course of the game. You sort of specify like which valences you might want them to have. So like your friends are good and they're read as producing confidence and like mitigating depression or something like that. And then the system generates a whole bunch of different game designs that try to get at that rhetorical analysis of what the game means. And you can see on the right-hand side here, this is like kind of a playable game example. These are a bunch of cards that kind of define the rules of this game in particular. And you can sift through this batch of games that are generated and kind of grab the pieces of the rules that you do and don't like, add them to your intent, and generate more games that kind of incorporate your revised or updated design intent. So you're kind of gradually, interactively constraining this space of possible game designs, which is very large, to narrow in on the ones that you think are close to what you're trying to get across through gameplay, the sort of meaning or artistic intent that you're trying to convey. And then when it comes to these more neural network kinds of creativity, systems like Meet the Ganimals by Ziv Epstein et al. Are kind of an interesting example here, where you can kind of look through the space of lots of latently existing creatures in a GAN-based image generation system that's kind of been trained on lots of little sort of like weird hybrid creatures, and try to sort of merge together using a bunch of different sort of genetic parameters, these different critters, and sort of find new ones that are interesting to you. And this is a social system, so you can kind of like gradually evolve this population of different creatures, and people can sort of point out the ones they think are interesting, sort of like make manual crossovers. The ratings by other people sort of like incorporate into the like sort of further surfacing by the system of new creatures. And in general, this kind of evolves towards these very strange little hybrid animals that have like some underwater sort of characteristics and also kind of look like a dog or whatever. And so these are both examples of mixed initiative creative interfaces where there's some kind of generative model under the hood, either a symbolic or a neural one. And we're kind of using some interface on top of that to steer or navigate within the space of artifacts that it could possibly create. And in these systems, creating an artifact is basically equal to discovering it within a very large possibility space. There's lots of things that could be created or instantiated, and your task as the user is to kind of curate or really narrow down or refine that space to find just the individual artifacts that are of interest to you in some way. Now, when we try to do this kind of analysis, when we're doing purely generative model sort of characterization in the sort of game design community, we have this idea of expressive range analysis. You kind of look at all of these different things that could come out of a generator and visualize them on sort of a two-dimensional heat map according to computationally accessible characteristics of these individual artifacts. Here we've actually got a bunch of level designs that have been sort of created for like a Mario platformer. And we have these two different characteristics called linearity, which is kind of the straightness of the path from the beginning to the end of the level, and leniency, which is the proportion of sort of automated playtesting runs that succeed versus fail on getting through this level. And we can generate, like thousands and thousands of individual game levels from our generator and plot them all on this sort of 2D heat map to see the typical distribution of artifacts that this generator produces on its own. So when we sort of sample from this level generator in an unguided mode, we can see that there's like a correlation to some extent between linearity and leniency. There's sort of like a center of mass of the typical levels that get produced over here. There's a handful of outliers that kind of live in these like very dark corners of the map. But overall, this gives you kind of a fingerprint or a portrait of what this generator tends to do in a particular semantic two-dimensional space. And if you define more of these quantitative metrics, you can do a bunch of different little sort of plots that kind of pair these metrics with one another to see correlations and assess generally like the way that these metrics do and don't relate, and also what's typical or atypical for this generator to produce. Yeah. So far, these are all about artifacts themselves. We're going to get to the process thing, but this is kind of the baseline that we used when there was just a computationally creative system producing artifacts entirely on its own.
Hi there, quick question. So where did those dimensions come from?
Yes, so these are created based on just looking at the problem of game level design and thinking about what parts of game level design could be usefully computationally characterized. The person who made this generator also made up the metrics. It's important for these to not be the metrics that the generator itself is using to steer its own generation, because obviously then you'll just see like the same things that you're putting in as your sort of like hyperparameters coming back out. But if you have these sort of objective computational characterizations of a game level that aren't related to how the game level generator is doing its generation, then you can start to look at a bunch of different game level generators in comparison to one another and see how they all sort of fare on this plot.
I guess I was asking more like, how do you know you have a good dimension or a good set of dimensions?
Yeah, and there's no really good principled way to know that, I think. In practice, the way that we come up with these is a hybrid of what things are easy to computationally characterize about these artifacts. So if it's like a bunch of poems, for instance, you might look at like word count as an easy one to characterize because it's just like easy to parse that out computationally. Some of them are going to be taken from the literature on like aesthetics around this particular form. So you might look at like assonance or sound devices, another thing in poetry that's like a little bit harder to computationally characterize, but still possible and drawn from the literature. And then some of them might be, you just happen to have like an automated playtester lying around, and so you try to come up with some metric that's based on that automated playtester. They're kind of coming from all directions.
So about that, where would human-generated games of the same type fall? And with the question of how to find the good dimensions, you could say that, okay, in human-generated games that I know have certain characteristics, right? They are for casual players, they are for hard players. You could select the dimensions that actually give you the largest discrimination between those two extremes. So that could be a way to evaluate dimensions in regard to their ability to kind of highlight some ground truth that you could define.
Absolutely. And so these sort of linearity and leniency metrics are both attempts to characterize difficulty in various senses. However, there's other ways you could also characterize difficulty. And once you have a bunch of these computational metrics kind of candidate defined, you can then do what we call metric selection to figure out which ones are the good ones. So Ollie Withington, for instance, has done a lot of work on, given a bunch of different metrics you could use, which are the good ones. And I would point to that paper as like a good sort of starting point for that kind of work. Cool, okay. However, if you have a user interface on top of this generative model, and you're not just trying to characterize what the model itself does, but also what users do with it, then there's a whole bunch of new problems that might emerge, which are not readily surfaced by this kind of underlying expressive range plot. If the user interface, for instance, is limiting access to some parts of this expressive range, and like even though the generator could produce stuff that falls down here, the user is not able to get to that part of it, then obviously that kind of restricts or constrains what the user is able to do. If the expressive range is too wide or too narrow to actually meaningfully help users find or pick out the kinds of artifacts they're looking for, then obviously that would feel bad from the user's perspective. They're kind of like struggling to make the tool produce the kinds of things they want. Users might be biased towards artifacts that are very typical from the perspective of this generative model, where it's sort of oversampling from some corners of the space that are like highly dense in the expressive range, but are kind of pushing users together. So they're all generating the same kinds of things regardless of what they want to get out. Users might be pushed to converge too early when they'd rather explore more broadly, or they might have difficulty converging when they want to. They might be sort of stuck in a divergent, like sampling from random parts of the space mode. And a lot of these methods are hard to, or a lot of these problems are hard to discover through conventional user study methods alone. So we kind of need new techniques for that.
And so the users, we assume that they know how to generate the artifact.
Yes, or at least that they're using the tool successfully in some sense. Like they're able to like figure out at a basic usability level, like what buttons to push to get a game level out or an image or whatever.
But are they creatively experienced in generating it?
Yeah, so this depends on the specific people you're working with and on whether this is a casual creator tool, which is for random people who don't really know this creative form that well, versus a professional creative tool that's like designed to support experts. And some tools obviously are trying to be both or like have aspects that are both. Cool. And so given all of that, oh yeah, question or no? Okay, cool. Expressive range coverage analysis is this extension that I developed during my early PhD, or actually late PhD work, on how do you sort of work with these expressive range diagrams, but treat them as the backing to an analysis that's based more on an individual user moving through this space. The idea here is that, again, we sort of construct these histograms by evaluating lots of artifacts produced by the unguided generative model operating in the fully autonomous mode, just kind of like generate thousands or like all the possible artifacts and see what it looks like. Then, on top of that, we ask a small number of users to each create several artifacts using a particular mixed initiative interface on top of that generative model, maybe a particular poetry composition tool or a particular game level generator or whatever. And then we visually overlay the user-created artifacts as like sort of a scatter plot layer on top of this expressive range histogram, maybe also looking at the sequence or the order in which they produce these artifacts, which allows us to start seeing these trajectories or user paths through the expressive range. We did a case study on this with Redactionist. This is this kind of poetry tool I showed you for a second as well, where we kind of sort of take an input text and erase all the words in it, except for a handful that are sort of made interactive. And you can kind of click on these to interactively say, I want this one versus I don't want this one. And whatever's left over at the end of this process of sort of interactive poetry creation is a handful of words sort of picked out from the source text that constitute the poem. So you're kind of making a poem by erasing most of the words in a source text, and the computer is helping you choose words that might fit well together in some natural languagey sense. And when we look at a few different users kind of piloting this tool, what we see is that different users have very different uses experiences in terms of like what kind of poems they create. This is kind of an expressive range histogram showing the average word position, or like where in the text the words were taken from in this particular user's poem, versus the distance between the first and last word. So like how much of the source text they're kind of covering when they sample from it. And so different users are sort of using this tool very differently in terms of the poems they get out. We can see that the user who has the red poems here is kind of clustered in this part of the expressive range. We see that the user with the orange poems is kind of sampling from this sort of corner of it. The blue poems are kind of clustered down here, and the user with the green poems is kind of all over the place. And so each of these users are kind of picking a different home region in the source text to sample from. They kind of focalize, given the same input text, on certain key words or phrases or parts of the text that they're more interested in exploring or playing with using this poetry tool. And they don't tend to all do the same thing. So that's kind of interesting to see. There's kind of broad coverage of the space, even though individual users are behaving very differently. We also see that although users are collectively covering this expressive range well, the poems they create are mostly unusual relative to all of the possible poems for the same source text. You can see here there's a very like sort of tight cluster of center of mass poems, that this is what the generator kind of wants to produce on its own, given this source text. A lot of them are kind of typical in this particular sort of corner. But most of the user-created poems fall on these shadowy regions off to the left and down to the bottom here, and even up to the top, where it's very unclear that there's any poems that the system could, in theory, produce, which seems to indicate that the users themselves are almost pushing away from or avoiding the center of mass of this particular generator's output. They're kind of trying to differentiate themselves, maybe, or they're more interested in exploring the corners of the weird regions of this space than they are in the things that the poetry generator tends to do on its own. We can also look at these per user trajectories. This is a very, very poor encoding, I think, in terms of like the sequential visibility. But we kind of use this gradient to indicate like, here's the first poem someone made, here's the second poem they made, here's like the third or fourth poem, and so on. We can start to see that this particular user started out kind of in the center of massy area, zigzagged a bit to here and to here, and then started sort of gradually moving this way, and then jumped up here and down this way. So over time, this participant is kind of gradually creating poems from words that are drawn from later in the source text. They're kind of sampling from the end of the source more than the beginning, and towards words that are very unusual to be included in a poem at all from the perspective of this particular generator. So they're kind of making poems that are weirder and more from the end over time. And when we look at these trajectories in comparison, we can start to see sort of shared interaction dynamics between multiple different users. A lot of them exhibit what we call this curiosity zigzag of having a home region they'd picked out, maybe this one for this user, this area for this user, this area for this user, and probably this one over here for this user. But then also kind of going back and forth between that home region that they kind of keep returning to, and these further flung corners of the expressive range that are all over the place. So this person in particular is very interesting because their first and last poems are both from nearly the same area, but they also explored over here, they explored up here, they explored over here, and in general created lots of really weird things. And some users in particular seemed really dedicated to probing the boundaries of the expressive range. This idea of curious users of casual creators, where a certain user archetype of these like sort of casual, approachable creativity tools tends to just push the tool in some direction as hard as possible to see what it can be made to do. And you can even see that these plots are kind of pushed down by this very, very sort of individual, distinctive artifact that P4 made as one of their last poems. I think their second to last or their last poem ever. Yeah. Yeah, so in this particular system, I think the incentives are mostly curiosity. There's not really like a reward you're being given for getting further out semantically. There's not really any kind of like specific task you're trying to accomplish. We just kind of gave people, here's your source text, here's the tool, make 10 poems, see what you can do. But I think everyone who was in the study had some appreciation for like the poetry, like sort of aesthetics. And so they were trying to do things that were either aesthetically interesting to them or that just kind of like sparked their curiosity in some way. Yeah.
If like a similar group of poets were to create something, because certainly an erasure poem, it has a constrained set of rules anyway, what would that look like if they weren't using this tool at all?
Totally, yeah. I think you definitely see a lot more diversity or variety in like which words are getting sampled. You definitely see a lot more sort of unusual use of like partial words. This is kind of a word-based chunking, so it only allows you to pick like one word either on or off at a time. And it's also kind of forcing you to be grammatically constrained, and that is trying to sort of make sure your final poem consists of a sequence of like grammatically correct sentences in a very loose sense. So a human erasure poet would do all kinds of weird stuff that doesn't conform to that sort of grid. However, that would also create an overwhelming number of choices to like sort of overwhelm the computational or the casual user. And so this is kind of deliberately trying to make it so that like a person who's never done erasure poetry before can jump in and get out something that feels kind of satisfying within a few iterations, as opposed to being just overwhelmed by all the possible things you could toggle on and off. Yeah.
Point is that the words have to show up in the order that they are in the original text, right?
Yes, yeah, yeah.
I mean, which is interesting, and I don't write poetry, so I really can't speak to how poets edit poems. But when I edit other kinds of literary things, I edit at different scales. I mean, so sometimes I'm editing locally, but sometimes I'm actually going to reorganize it, and huge chunks of text will move from one place to another place because that's what you ended up doing when you wrote that paper. So maybe you could comment a little bit on kind of even the sort of grain size of the editing that's involved in here, because this limits you to a very specific grain size and
yeah, absolutely. So I think this is like very specifically like one tool that's trying to make it easy to create poetry from like random web pages you found or whatever. The initial version of the generator was actually a browser extension that you just go to a website, click a button, and it turns it into erasure poetry without any human input. And we made it more interactive gradually as a result of like wanting to have more authorial input into how the poems got produced. I think if you were trying to make like a serious poetry editing tool, which we've also worked on more recently with things like Phraselet, which is a different system, then you'd want it to be much more open to like rearranging words and like doing cut-ups and like all these other sorts of like writing techniques and editing techniques that have nothing to do with taking like one passage of source text and reducing it down to an erasure poem. But erasure poetry is kind of fundamentally constrained by the order of the words in the original input. And even though sometimes people do creative stuff with like drawing rivers between two words, where they kind of like make it clear that they're trying to get you to read in a different order than the original author intended, there's still that sort of fundamental material, sculptural sort of aspect to it, where the dialogue between what was there in the first place and the poem that you're kind of pulling out of that original material is kind of fundamental to the aesthetic interpretation of the poem as a whole. And so I think when it comes to erasure poetry specifically, the editing sort of like dimensions are very different than they would be for other kinds of text. Totally. Yeah. Mm. Yeah, totally. So in this particular case, we didn't do that comparison directly. You can kind of see that on the expressive range trajectory plots here, or like the coverage ones especially, where you can see that like users are like over here and the system itself is more over here, given the same input text. But this is also the kind of thing where you can try to start comparing, like in the game level context, people have taken Mario levels that were made by the original Mario game authors and tried to draw the same kind of histogram around them using kernel density estimation, and then compare that to what a particular level generator is doing. And they often have like nothing to do with one another. So there's a lot of weird discrepancies between how we construct these computational systems to do generation and how the human who has like been an expert in this domain for some number of years has like decided they're going to approach the space. So that like overlaying these plots on top of one another when it's like from two different authors or two different sources can give you a lot of really strange insights into like what does a human do and is it typical? And the answer is often no from the generative model's perspective. Yeah. Go for it, yeah. Yeah, not in this study, but in follow-ons we have, yeah. And people behave very differently, especially people who are like experts in a particular form of poetry or like sort of experimental writing broadly, tend to have like an established practice that they're trying to impose on the tool or like get the tool to facilitate, versus people who have no established practice tend to come in much more open-mindedly, but also not know how to evaluate their own work as well. So they do things that are like stranger and more divergent, but also more in line with the tool's affordances in an interesting way. Yeah. I'm going to go fast through the rest of it, so yeah. Uh-huh. Exactly, yeah. 100%. So that's going to be actually one of the next things I talk about. Cool, yeah. Cool. Okay. So given all of this, it's kind of neat that you can kind of look at all these different aspects of the expressive range at once. You can kind of turn it into a quarter plot and just look at like a bunch of different metrics compared side by side. And remember, all of this is based on this premise that creating an artifact is equal to discovering it inside a very large possibility space of different things this generator could make. However, when we're trying to build mixed initiative interfaces for more open domains that aren't as constrained as blackout poetry, for instance, what if the possibility space ends up being too large to systematically enumerate? You can't just get a generator to produce every English text and then look at how the human-produced ones fall in relation to like everything that a generator could in theory do, because there's lots and lots of different words. You can put them in lots and lots of different orders. It's like unbounded in like the length range. So even if you like put a cap on it, you're still dealing with like these massive combinatorial spaces of like every possible arrangement of words that might possibly ever make sense. And so when you start doing more aggressive like compositional stuff, like for instance in Patchwork where you're kind of bringing together images and text to define a world or like a story Bible for a sort of fictional setting you're creating, then being able to do this kind of analysis becomes much more difficult because the underlying expressive range is very unclear. You have lots of different images you can bring in. You can generate more images. Every image itself is an arrangement of many, many pixels, which are not individually like sort of syntactically even meaningful, let alone semantically. And when you look at the way that these arrangements happen, there's kind of like a narrative flow being imposed from like the top left to the bottom right, but it's also kind of using both text and images to convey meaning. And there's these entities like, oh, someone's created a prop that's called the danger flowers, and the danger flowers are like delivered as this malicious gift from one vampire to another. And there's all this like sort of weird stuff going on that is very hard to characterize in relation to some particular imputed generative space of all the different patchwork worlds that could be created, or all the different canvases you could instantiate. And so when you're working with these more open-ended generative AI systems, where you're generating like open-ended text, generating open-ended images, interpreting both of those that come from users, then you can't really easily do this kind of expressive range coverage analysis where you look at everything and then look at user artifact in relation to that directly. So what do we do instead? There's this idea of linkography that comes from creativity studies in the early 90s. And they were originally kind of doing it by looking at the architectural design process. They had a bunch of architects in a room together kind of co-designing a building. They were sort of like sitting around a sketchboard or like a table kind of sketching and talking. And everything they did or wrote down or everything they said would be kind of like noted by a human transcriber who was just like writing a massive list of all the things that happened. And then that transcript would be parsed into design moves, which were individual chunks of text corresponding to a particular update to the design situation. So this might be something like the first design move is someone says, we need a shed over here. Someone else says, we need to paint the shed red. Someone else is like, the door needs to be able to swing both ways because this needs to be able to get in. And then someone says this like ignored digression that's like, oh, well, actually we need to like account for this slope, that the slope is gonna like make it really hard to build the foundation or something like that. And when you start to chunk out these moves, you can draw them left to right on a timeline. So like 0, 1, 2, 3, 4, et cetera. And then look at the patterns of links or references between them to sort of see where ideas are introduced that get built on or developed later on versus where ideas are kind of ignored or not paid attention to, and when ideas are kind of referenced at longer range versus only at shorter range. And there's a few different kinds of patterns that tend to emerge in these linkographs. In the front here, we have a web, which is a sequence of moves where all of them are related back to one another. So like everything touches everything else in this sort of like 0 to 3 sequence. Over here, we have 4, which is an orphan move. This is something that someone says that's just like completely tossed out of the discussion. Like no one responds to it, and it's not responding to anything else. Over here, we have a looser chunk of moves, where like move 5 kind of introduces an idea, that then like move 6 develops a little bit, move 7 develops in a different direction, move 8 develops move 6, but doesn't refer back to 5 directly, and then 9 itself is also like a reference to 5 again. And then at the very end here, we have this sawtooth structure of several moves that each are like a direct like ping pong response to the previous move, but there's no like cumulative development of an idea throughout it. It's just like one thing, second thing, third thing, fourth thing, et cetera. Like 2 people going back and forth often looks like this. And so when you look at these structures, you start to be able to see how these different sort of give and take patterns emerge between different actors in a creative situation. However, this is typically done by hand, and that makes it almost impossible to scale it up meaningfully. If you're observing architects doing this kind of thing, you've typically got like a human there who's like sitting there noting down everything that gets said. Then you've got like a bunch of different coders who look at the transcript and try to like pull out different design move encodings of it. And then you have like 3 different people all draw the links between them to try to assess like which moves are actually related or meaningfully sort of like building on one another versus which ones aren't. And even if you have like an army of undergrads doing this, this really restricts the scale at which you can possibly apply this kind of thing. So using it to like characterize large numbers of creative interactions is very difficult. In practice, you often see papers that are either like, we wanted to use linkography, but we couldn't because it was too costly, or we did, and we went up to like the dozens of trajectories scale before we got like sort of overwhelmed and couldn't do anymore. And so like as a technique, this I think is very interesting because it allows you to see these co-creative interaction dynamics, but it also is very hard to scale in a meaningful sense. So what I've been working on lately is this technique called fuzzy linkography, where we try to generate these linkographs automatically, and although they're imperfect, can still get some interesting, meaningful structure out of them. So here we have kind of me just sitting down doing stream of consciousness ideation to sort of like test out the tool. I said, hello, hello world, dog, cat, zebra, horse, hello horse world, hello kitty. That kind of brings together a bunch of these different themes. Stream of consciousness, I kind of got stuck here, so I said something random. Kitty, cat, not much money in the kitty, piggy bank, riverbank, stream, video stream, cat video, Hello Kitty TV show. And this was so clearly the unifying idea of the whole session that I was like, I'm done here. This is like mic drop, I'm out. And so you can sort of see the link structures here being inferred by this embedding model, where we look at semantic similarities between these different ideas that have been introduced and kind of look at the strength of these links to visually assess that. So like hello here, for instance, is kind of introducing the theme of greetings, which is developed a little bit in Hello World. As referenced more later on by Hello Horse World, Hello Kitty especially. Hello Kitty also refers back to this idea of cat that was introduced later on and sort of like this animal sequence. Kitty Cat kind of integrates a lot of these things. And then like Hello Kitty TV show refers back to like Kitty Cat and to Hello Kitty and to the initial hello and like a bunch of other things. So you can see that this sort of like link structure is also accessible, even though this is kind of like an unreliable or fuzzy model of which links might actually exist, as long as you're able to visualize the uncertainty that comes out of it and kind of treat some links as weaker or stronger, depending on the semantic similarity assessment between these different sort of textual characterizations of design moves. And so if we collect lots and lots of different traces of creative activity, maybe thousands of them from Patchwork or something like it, you might be able to do this to all of the image prompts people do in a long sequence, and start to visualize all of those different interactions and make sense of them in that way at scale, which is in fact what we did. We looked at these 6,424 sequences produced by Patchwork users after this sort of like 2-week testing period at the end of 2024, and started to be able to like visualize all of them very rapidly and start to see the recurring patterns between them. We see a lot of things we've given names. One of them is these recurring patterns of refinement webs. The idea here is that you can sort of see one of these refinement webs here, one of them here. And this is a sequence of moves where, again, everything is related to everything else, because these are sequences of image prompts that are all very similar to one another. And they tend to indicate a sequence of retakes or refinements to a single prompt, kind of converging on a particular goal. So someone starts out with a very vague idea. They try a bunch of different divergent stuff at the beginning. Some of it's related, some of it's not. But then they sort of realize this is the prompt I want to use, or something very like it. And then they try like that same thing a few different times, either like just mashing the retry button until they get an image they like, or they make very small adjustments to it incrementally. And you can sort of sometimes see the like strengthening of the links from left to right as they make smaller and smaller changes to their prompt, getting towards their goal. We can also see what we call a curiosity zigzag. I've mentioned this term before. It comes up in the expressive range data, but it also comes up here, where you can see people kind of developing a central theme that they keep revisiting. There's sort of a zigzag pattern of strong links between the different instantiations of the theme, but also these other unrelated ideas. There's like a lot of orphan moves towards the beginning here. There's an orphan move here. There's this cluster of things that are almost entirely unrelated to anything else that happens in this particular interaction. And what the user was actually doing here was like building a world where they had some central concept, but then also decided to make like a self-portrait or something in the middle in the same sort of like physical canvas space. And so you can see that the prompts here are like almost unrelated to the things before or after it. And meanwhile, there's sort of the central theme they keep coming back to of like the central premise of this world. We also see hybrids of these patterns, so like a converging zigzag here. This is one of my favorite of these linkographs. It kind of sums up a lot of these ideas. What we see here is that there's sort of like disparate interactions at the beginning where they're trying like different ideas out and seeing how they fit before they're gradually integrated into a single theme. In particular, we first see someone coming up with like a sort of central character idea of an old man, a cute old man, I think they were calling it. And then a different one, a man with the head of a tick, is kind of brought in. And then gradually, during this refinement web, where the links kind of get stronger and stronger as the prompt changes get smaller and smaller, they sort of hybridize those characters into a single subject, which becomes their main character for the rest of their prompting. There's kind of a temporal break in prompting here, where they walk away for at least 30 minutes. That's indicated by this vertical dotted line. And then we see them starting to merge this subject together with a bunch of other stuff. And the other stuff is actually a visual theme they've been developing, a visual style, based on manga and like some sort of like black and white Kodachrome film thing being sort of like merged together, that started to appear in the very beginning, but not in conjunction with that character. And then at the end, we see this massive refinement web, which is actually kind of like temporarily split by another break, where they sort of like try a bunch of things where they try to merge these ideas together. It doesn't quite stick, even though they try like the same prompt a couple times at the end. But then they come back after a while and manage to merge it into a thing that satisfies them. And we sort of finally see this like integration at the end. Yeah.
So how do we know what we are seeing, right?
Yeah.
So humans are amazing at finding patterns on things. And so do you use some kind of strategy with a null model to decide, oh, this is a pattern, it appears more than I would expect at random? So what's the technical approach there?
Yeah, so what we actually did here was look for the same kinds of structures that we see in the linkography literature. So these are things that people had like sort of defined via qualitative coding and thematic development stuff before. Yeah.
I'm curious, how did you decide on, you know, work that thought different, like I can imagine looking at photos.
Mhm. Totally, yeah. So this is relatively low-hanging fruit in the sense that we already had like a nice structured record of all the image prompts each person did in this particular tool. And so like in this particular case, it happens to fit this idea of just embed every prompt and like look at the similarities very nicely. I think when you're doing things with like Photoshop, for instance, the granularization of those actions, like the choice of granularity or like how to chunk those actions, becomes a much more interesting question, and one where there's like a lot of ambiguity in like what an action consists of or like a design move. But then you could sort of imply the same like sort of chunking things that were done in the human annotation process with the old school architecture analyses, and then also maybe start to develop some kind of like model that's based on human annotation of transcripts where you say like, well, actually these 5 actions were all like one semantic action from my perspective, and like develop a thing that can do the chunking automatically. Yeah.
Between 2 red dots. The links between 2 red dots are via a qualitative approach by humans or by like a large language model?
So in this case, it's actually an embedding model, a sort of sentence similarity thing, where it's looking at like not full language modeling capabilities, because that would take too long to do for all these pairwise sort of assessments, but also not a human sort of like manually sitting there and doing it.
And then did you do some way to like double check that that actually was working? Like there's a human kind of validation. It's like, okay,
Yeah,
this
yeah.
generally works.
We're actually using the same embedding model here as we used for a previous ideation study that is going to be touched on very briefly in like one of the next few slides. And there we kind of checked that this particular embedding model aligned well enough with human assessments of semantic similarity that it was like useful in this creativity assessment sort of direction. Yeah.
described it, you actually added a gloss around basically the dimensions that were being, like one of them was about the content, like there's the cute old man and the head of the tick kind of thing happening. And then there's another thing happening, which is around stylistic issues of the image style, let's say. And I mean, I think it's good that this analysis kind of evoked that in you, but it would kind of be nice to think about how that kind of analysis could actually come to be automatically as well, that it's not just structural, but you get this kind of, oh, here's where they merge this stylistic thing with this content thing, for example.
Absolutely. And I think that's the kind of thing where having an actual language model look at the outcome of this might be interesting, where you can start to look at the texts of each move and like sort of summarize at this point, like this is kind of a pattern that seems to resemble like someone trying a bunch of incremental retakes, but this is also about like merging together these two ideas or whatever. We haven't done that yet, but I think it's a pretty natural extension. Cool, okay. So we also see some interesting temporal dynamics here. Some users kind of like prompt in very clearly temporally divided sessions where they like do a bunch of stuff on some theme and then walk away, and then everything they do after that like doesn't touch the stuff they did before, basically. And in contrast, some users have these long-running projects where they kind of develop the same theme across many different temporal breaks. This is kind of an interesting one where someone was developing like an avatar-themed like sort of fantasy world, and each of these clusters of sort of like tightly related moves, these refinement webs, indicates the development of a particular image of like a setting or a character or a faction from this overall world. So they would develop like, here's a particular tribe that exists, here's like the person who's running that tribe, you know, here's like a particular place that they all go, that sort of thing. And you sort of see these retakes over and over again, converging on a definitive image of that particular theme or idea that exists in this overall setting. Okay, so given that we can do this kind of analysis now, can we use this to build more proactive creative tools? Things that kind of look at the interaction as it's unfolding and maybe figure out where to intervene or how to intervene to perform certain kinds of adjustments to the direction the creative process is going. Obviously, we can do a little bit of adaptation here by just looking at the clusters of linkographs that emerge to see if there's different designer archetypes that might exist. Different sort of like characteristic usage patterns or behavior patterns that fall out of looking at the structure of these sessions that people are doing. This is a very naive clustering. It's like a very first pass, like k equals 5, k means clustering. But already here, we do start to see that there's some interesting similarities between the ways that people are prompting up here versus the ways that they're prompting down here, where there's like one giant fixation that they keep coming back to. And like a lot of their images are like almost the same prompt. They're going for like a single image over and over and over again. And then people use it more or less sparsely. You see like lots of relatively like ongoing, like long-term usage up here versus sort of like shorter sessions that are more divided. And then, of course, at the end, we've got like this interesting mix of short-range and long-range links, regardless of how long the session ends up running. And so these could probably be used, if you especially refine the clustering, to automatically adapt the user interface of a creativity tool or the AI backend of the creativity tool maybe towards these different people's usage styles, trying to figure out like the archetypes of different designers that might be out there and how they might prefer to use this tool or how we can shape the interface towards their interests. In addition, though, we did this other recent study comparing these two different tools as ideation support tools. One of them is ChatGPT 3.5. This is a little bit while ago. And the other is this oblique strategies deck, which is kind of a deck of cards with a bunch of weird short prompts printed on them that you kind of pull out and try to incorporate into your creative process. This was created by Wed NICO and Peter Schmidt in the 70s. They were both kind of like artists slash musicians. And the cards say things like, make a sudden, destructive, unpredictable action and incorporate. So you pull one of these out. It has something to say about what you should do creatively, some piece of advice that you should follow. And then you try to like update your creative process or come up with a new idea in response to whatever it says. And so when people kind of use these two tools against one another, we kind of split this group into people who are using like ChatGPT for certain tasks and oblique strategies for other tasks in a way to make sure that we get people from like both sides working with those tools. We start to see that there's obviously more homogeneity coming out of the people who are influenced by ChatGPT in their ideation. When people who are like different users are all using ChatGPT for the same ideation task or the same ideation context, they produce ideas that are more similar to one another's ideas than they would to like if they were just using the oblique strategies deck to do the same kind of ideation task. However, we also see that people using ChatGPT kind of win on other metrics. We have these traditional sort of like TT-CT, like Torrance tests of creative thinking dimensions that we look at for creativity assessment in the conventional sense. And so here we have things like flexibility and fluency and elaboration, basically like the extent to which people cover different idea categories, the extent to which they develop lots of different ideas, and the extent to which the ideas are like developed to a more elaborate extent, how many words are used to represent them or how many keywords or something like that. And so in each of these cases, we see that people using ChatGPT tend to perform better in some sense on creativity, while also being more homogeneous at the group level with respect to other users in the same situation. And so we were really interested in this question of characterizing how the influence between the human and the machine might lead to these outcomes. And so here what we do is what we call multi-actor fuzzy lithography. We kind of look at the human moves, which are denoted as red here, and the machine moves, where a machine introduces an idea, denoted as blue here, and kind of note down for each of these ideas that they came up with in this session, like how much each one is similar to the other ones, the same way as we did before. But then using link colors to indicate machine-to-machine connections, human-to-human connections, and the purple ones are kind of human versus machine, like sort of merging ideas together or sort of saying things that are similar in some way. And so what we see here is a lot of recurring interesting patterns again. For one thing, we can see AI misfire as being very evident in this graph. This first batch of machine ideas that are all from the single prompt that the user did are completely unintegrated. Like the user doesn't touch them again, the machine doesn't touch them again. They're like unrelated to anything else that's done in the whole rest of the session. And so it's interesting to see that like this is basically immediately ignored and the user doesn't sort of like go back to this at all. They just prompt for more ideas and sort of start using these more. We can also see that user ideas early on tend to be pretty diverse. There's not a lot of strong similarities between these or even between these because people are being prompted to think divergently and sort of instructed that they should come up with as many different things as possible. In contrast, we see that ChatGPT is generating these very large batches of ideas all at once. If it was you and another person sitting down and sort of co-ideating, I think you'd probably be overwhelmed if someone came up with like 10 ideas all in a single giant batch. But that's kind of the typical output of ChatGPT 3.5 in this context. There's like a list, a numbered list of like 10 ideas. We split them up into individual moves here and can sort of see that like there's this immediate textual overwhelm effect that happens where users sort of like see lots and lots of stuff coming from the machine at them. ChatGPT ideas tend to be more related to one another than user ideas. So we see stronger links here, and the links actually get stronger from left to right as we sort of proceed through the session. So relatively diverse user ideas, relatively similar to one another ChatGPT ideas, and the links are getting stronger as the machine is sort of conditioned on more and more of its own output text. And yeah, as we sort of see this pattern strengthening throughout the overall session, we see here that like this is almost the same idea as this one in some ways. And a lot of things where the machine is kind of referring back to its own output tends to characterize the interaction overall. Yeah, blue is machine, red is person. We also see users sort of gradually switching over the course of these interactions into what we call a curationist mode, where they're more focused on filtering and integrating ChatGPT output as the session comes to a close. Here we see, for instance, that the user initially comes up with their own ideas for the first few, uses a bunch of prompting to try to get things out that they like, doesn't like any of them that much, so comes up with a few more on their own, comes up with some that are pretty similar, like variations on a theme over here, and then tries to integrate a ChatGPT idea where they kind of like paste part of it and modify the text lightly to come up with like a sort of modified version of a machine idea. They prompt again, get a different batch. Here they again try to integrate like the first of those machine ideas especially into their own thinking. They prompt one more time, get a batch of very similar things, and then at the end kind of spend a few minutes grabbing ideas from earlier in the session and remixing them to sort of like merge them together or curate the best of the ChatGPT output into like a few smaller number of ideas. Yeah.
Have a longer context, and actually here it looks like the human being is taking the job on of maintaining the context of the whole thing over a longer period of time.
Totally.
In some sense, yeah.
Yeah, so I think also here with ChatGPT 3.5, it's like less good at taking into account like a long context window. However, these conversations didn't tend to like overflow the context in practice. These are like 30-minute study sessions more or less. And so we generally see the chat window having like a few messages in it back and forth, which is not enough to overwhelm it at that point. I do think that the machine tends to see a lot of its own text in the transcript, especially as the conversation progresses, because it generates so much more per turn than the human does. And that probably puts it more into a imitating or replicating its own prose sort of direction, where it's like biased towards its own ideas even more strongly as things proceed. The other interesting thing here is that the person often is saying things out loud to us about what they don't like about the machine output that they're not putting back into the conversation. And so this is kind of an interface limitation in some ways. We can't get people to say to the machine what they want to see changed, so the machine can't take it into account. I mean, it could be. I'm also not totally convinced that it's not an artifact of like the chat model, right? Where it's like, if it's a chat conversation and you're like trying to minimize your amount of input into it, like prompting again or more or something like that is a lot easier, I think, than like actually articulating what's frustrating to you. And people might not trust the machine to be able to take that feedback into account meaningfully, especially if they've tried it before and it hasn't worked.
Right. So you described the situation in which people are doing ideation, right? So the idea is there are no dumb ideas. We just put them all out. And so let's imagine that we are not talking about ChatGPT, but we are talking about a human, and the human comes in and does something completely different, right? It's instead of being on the branching side, they are kind of on the focusing side from one idea. That would be very highly frustrating, also because it seems to win in the end, right? So
Yeah, and so this is like the overall problem, I think, with this chat model in some ways for an ideation support context. The machine overwhelms you with lots of stuff. The stuff that it says gets more and more similar to other stuff it said as it proceeds. You're trying to get out into more divergent directions, but it's getting more and more convergent the more you push it. And you've already sort of exhausted or seen the diversity that you're able to get out of it with your initial prompt ideas. And so I think you tend to get exhausted creatively as well as this sort of pushes onward. So you end up in this more curationist mode where you're filtering or integrating machine output, and then the overall thing becomes increasingly you just passing along bad ideas from the machine. And so I think this is one of the big limitations of this kind of system right now.
Right, and it would talk about a huge problem at the heart of the development of these things, right? Yeah. So because I'm thinking about, would the machine be my junior partner or my boss? And in this implementation, it seems to be taking the boss job, yeah, right? And so now I'm the junior partner, kind of fine-tuning the machine. Doesn't feel particularly good, I would imagine.
Exactly. And so I think this is one of the reasons that we should probably move away from this approach to designing the interactions with these machines in a co-creative context. I think we really need something that like elicits more intent from the user and lets you do a lot more of the guidance. And the machine might need to be changed in how it's trained as well to be able to like more meaningfully incorporate your ideas. I think we've even seen some progress in this direction with like the different chat personas that are adopted by more recent language models, but I don't think it's anywhere near enough. I think we really need like tools that are much more dedicated to like getting the user to put more of their own thoughts into the process, basically. I've written about this quite a lot. A few more things I want to get through before we get to the very end of this. We see that ChatGPT ideas especially are not building much on user ideas. The influence is mostly one way, again, because the users are not putting much of themselves into this conversation. They're not specifying to the machine what they want to see change, either because they don't trust it to actually adapt or because they don't think that it's like worthwhile or worth their time. And these dynamics tend to recur across lots of different ideation sessions, even under very different usage patterns, even at very different levels of overall link density. Regardless of how you're using it, some people had like really clever prompts they were trying. The clever prompts don't really change the dynamics that much. It's kind of the same thing no matter what you do. And so we can even look quantitatively at like the aggregate backlink densities between different actors' moves to sort of like summarize the influence dynamics. And what we see here again is that each actor refers back to their own ideas more than they refer to the other ones, but the human refers back to the machine a ton more than the machine refers back to the human, even when you don't take into account verbatim copy-pastes of machine output by the human. So like even excluding the copy-paste moves, we still see a lot more influence of the machine on the human than vice versa, which again puts it in kind of that boss or leading role that we really don't want. Okay, so I think this has a few interesting implications for co-creative interaction design. I think there's things that you can do around like trying to deliberately integrate ideas that have not been brought together in the session to sort of make proactive machine moves that kind of like remix or come up with new directions to go in, rather than trying to like sort of reiterate or regurgitate things that have been said before. I think periods of high and low creative momentum can probably be gauged from this to some extent. You can like sort of look at when people are coming up with lots of ideas that are very divergent versus convergent and tell whether someone's in more of a divergence-focused or a convergence-focused mode to be able to tell when would be a good time to say like something really wild and out there versus when's a good time to say something that's much more sort of like buttoned down or like developing a previously introduced theme. When the machine doesn't seem to be taking much influence from human moves, which you can kind of gauge quantitatively, that might be a particularly good time to proactively ask the user questions or pop a little interface that's like, do you like this one or not? And like maybe even prevent them from generating more machine output until they say more about what they want and what's good and bad. That kind of intent elicitation is a thing that I think is really powerful when employed correctly, but also has this risk of being Clippy-like. It can be this sort of like annoying pop-up in the corner that's like asking you questions when you don't want to be asked questions. So figuring out like when a good time to make that intervention is I think really important to making those feel smooth and like functional in practice. And of course, because this is an embedding-based technique, you can apply this to new creative domains, not just text. There exist good embedding models for obviously images as well, but also game levels, audio. I was just talking to someone this morning about that. User interfaces, there's a thing called UI clip that can be used to like sort of gauge user interface similarity in the same sort of semantic way. And all these additional creative domains are somewhat amenable to this kind of analysis, which I think is very interesting. This kind of gives us this idea of linkographic abundance. because we used to have this as a very scarce resource, this kind of like annotation of move relatedness over the course of a session. But now we can generate lots of these very quickly, even if they're kind of fuzzy. We can now start to build interactions around having these exist in real time, showing them to users maybe as like a reflection tool or like a thing to help them think about their own process. And we can start to integrate this idea with other kinds of semantic spaces. This is a thing that I'm going to talk about very briefly because it's like kind of new work that's still in the publication process. But we built this thing called Artographer over the summer. This is led by Shim Almeida, one of our visiting researchers. And this kind of embeds a bunch of museum collection data, both images and textual descriptions of those images, in clip space, and allows you to kind of jump around that space in sort of like a physicalized 2D map that's been U-mapped into this plane, by also allowing you to like sort of generate images to like jump around or teleport from one corner of the space to another. And the idea here is you're kind of like collecting images that might be inspirations or references for you in your own art process. And when we look at the way people move through this space, it starts to resemble kind of a weird hybrid of this fuzzy linkography where we're looking at semantic similarities very closely, and this earlier expressive range covered stuff where you're looking at like a planarized representation of the space and looking at people's movements or actions on that planar sort of like thing. And so we see here some familiar movement patterns. We see like jumping around. We see kind of like foraging or getting serendipitously distracted in this area. We see a lot of interesting things where they like sort of meander up here and then come back to their thing that they wanted before. And then we can sort of show this to people and let them debrief with us by talking about what they were thinking at certain moments in terms of this map navigation. We can even do the beginnings of what we think might be coverage analysis in clip space. And here we see again that like the artworks that people collect, the ones they sort of like decide to pick out as the most interesting ones to like sort of refer back to in their own work later on, disproportionately come from the outliers of this map. And the outliers of this map are kind of artificial because we just planarize clip space. So they're not necessarily like meaningfully outliers in a sense that like we can definitely see with the generative models that are producing like some artifacts much more rarely than others. But we see here again that the people seem to be driven by curiosity and like trying to push the boundaries in like a very literalized, physicalized sense. So regardless of what is on the outliers here, people disproportionately collect from those outer 15% margins of this map rather than from the center. And so I think this suggests a really interesting pattern of curiosity and again being driven by trying to get away from what the machine does by default. Okay, lots of stuff. I think I've answered a lot of questions already, but I'm happy to do more. Publications about this are all here, and more is coming soon. Thank you.
All right, we are at 1 o'clock, so maybe just a couple questions. And if not, we'll just
Since you're at Midjourney, I'm curious to what degree you did the linkographic analysis on the way users are using Midjourney, and to what degree that can inform how Midjourney then, changes its product.
Yeah, absolutely. So we didn't get to do much comparison with like the basic Midjourney prompting interaction that you see in Discord. We were mostly focused on data from the tool that we ourselves had deployed as a team because we had better access to that data. But I think we do see a very interesting comparison between other studies of traditional textual prompting for images and the behaviors that we saw in ours, especially around temporality. Because we had put people in this sort of like ongoing canvas space they could keep coming back to, and their past images were just like sort of there just staring them in the face when they revisited. I think we saw more thematic development and more like reiteration across temporality of the same themes over and over again, except in the cases of the people who were just like obsessed. And those obsessed people are obsessed no matter where they are. Like they just prompt the same thing in text over and over again. They prompt the same thing in the canvas over and over again. They just have like some image they really want to see a lot of, and they just ask for it repeatedly. But I think the other people who are like more focused on a particular creative project found our thing a little bit easier to use in terms of like coming back to the same themes over and over again.
Thank you very much.